Hello all, myself Shruti of Artificial Intelligence and Data Science Department along with my teammate Sanjay Raj. Our project is on Intelligent Inventory Forecasting System. This system is designed to make inventory decisions smarter by combining AI and optimization using graph for multi-location analysis, time series for demand forecasting, dynamic programming for decision optimization, and priority queue for reorder management. In simple terms, our project helps businesses to ensure right project reaches the right person at right time, minimizing both excess stock and shortages.
The need of the project is multi-locational inventory system which in complex demand and transfer challenges. Traditional methods are guess based on reorder points, leads to outstock and overstocking the losses. Managing inventory across multiple warehouses and store is very challenging. Traditional approaches often rely on static record points and manual judgments. As a result, same location face stockouts while automation with the process. Forecasting demands accurately and optimizing inventory flow with AI techniques.
So here is an overview of how our system works. We begin by collecting data from sales APIs, warehouse logs, and shipment histories. This data is processed into a graph structure representing multiple warehouses and stores. Then, using time series analysis forecasting models, we predict the future demand of each item. The predictions are passed to dynamic programming. Based on optimizer, the decision will be taken how much to reorder and restock. Finally, a priority queue engine triggers the order based on urgency, and results are displayed in a dashboard for user to monitor it.
The first major component is the graph model, and then each warehouse or store in represent as node transport routes between the edges with attribute like distance, transfer cost, and some lead times. For the forecasting, we use hybrid time series models like ProHip, SariMax, and some LSTM to capture seasonal and trend patterns. These forecasts from the base of the future demand predicts the ensuring and decisions from data with driven rather than guessworks.
Here, dynamic programming minimizes the overall cost by considering and holding the shortages, ordering, and transfer expenses. It helps in identifying the optimal reorder quantity and timing. Once optimized decisions are made, the priority queue engine comes in. It ranks reorder based urgency. For example, items at high risk of stockouts are placed at the top of the queue, ensuring the most critical orders that are executed on first.
We implemented the system in Python. Graphs were modeled using Network X. Demand forecasting was handled with Project and TensorFlow, and Fast API was used to create a backend API. The front-end dashboards was built to react for visualization and demand forecast, inventory status, and records alert. This historical sales data are shipment logs and leads to data where the main inputs were used to train and test the model.
To measure success, we use metrics like MAPE for forecasting accuracy, stockout rate, and holding cost. In our experiment, the system significantly reduces stockout by around 30 to 40% and improves service level up to 98%. This clearly shows that the integration AI forecasting optimizes and gives both efficiency and operational reliability with reduced cost.
Like any systems, there are limitations, mainly the need for the accuracy data and highly computational power for very large networks. For future improvements, we plan to integrate reinforcement learning for adaptive policies and enable real-time forecasting through API streaming. In short, our intelligent inventory forecasting system offers a smart, scalable, and data-driven approach to modern supply chain management systems. And both are together. Thank you for that.
Thank you.